Hello, I'm Giovanni Bechis, and an OpenBSD developer from Italy. I work with as a committer with OpenBSD for more or less 10 years, and I want to talk about security mitigation, which was added to OpenBSD a couple of years ago, and yes, it's quite stable and more or less definitive with the latest version of the operating system. I'm a system admin developer at SMB, which is my own software house in Italy, and I'm OpenBSD developer and as many of you, open source, developer in several other open source projects. There are a big set of mitigations technique in OpenBSD, like the stack protector to make sure that the process cannot alterate the stack or layout randomization or right substitute or more that. One of the important is in this context is privilege separation and privilege drop, because speaking about user land, you should have each software should run on its own username, UID, and group ID, and it should be created with more processes, the way that every process can access only limited set of files or limited set of things. This way, we will see that it's far easier to enhance the way you can protect with the software with pledge, and the way that, for example, adding mitigation support to well-written software is far easier than adding mitigation support to Firefox or big monsters like that. The problem has been a long-standing problem is the fact that we should disable system call a process shouldn't call. So ls, for example, shouldn't try to exec some other software or accessing sockets or something like that in any way. And there have been several attempts to, in different operating systems as well, to try to detect this thing and block this kind of problem. Security Enhanced Linux was one of the first, and it has at least a couple of problems. The first one is that it can be disabled. It has an enforcement by default, but it can be disabled by config file, and a lot of people, as first thing, that do when configure the server is disable unless the Linux, because they want to hack or change or configure this monster. The other fact is that it's very complicated to add the security context to all the software you have. It doesn't work out of the box for example, the most common software like Apache or Dotcot or the most common software. It doesn't work out of the box. You have to configure some stuff. Second is another technique that's been added to Linux. It has BPF engine and kernel. And the main problem is that, well, it's a bit complicated because you have to structured software to with some BPF rules, and the biggest problem is that it has a process that monitors that those BPF rules are how they have evaluated, but there's no process that monitors this process. So if it's a chicken and egg problem that cannot be solved this way, Capsicum is another try. The main problem with Capsicum is that you have to modify a lot of code to make it work well, and so it's difficult to add Capsicum support and to make upstream accept the patches and to maintain the patches that have Capsicum support. Then we had systrace, was developed around 10 years ago by Niels Provost for OpenBSD. It's configuration file based, so you have a configuration file in which you define which system call you should accept, but being configuration file it could be complicated to detect all the system call a software needs without starting the code, without trying all different switch, parameter switch, and so on. And it doesn't fit very well with some softwares. And then we decided to move another way and to add pledge. Pledge is a syscontrol, so it has its current interface that you style the code. It's been introduced in OpenBSD 5.8 as tame, and then it has been renamed to pledge. At the moment in base we are around 500 software with pledge support. Imports we have 50. The main reason of this difference is that a lot of developer knows very well all software database. There are not all that developer knows very well all the software data imports, because there are many codes. Another problem is that it's difficult to send upstream patches to pledge and to maintain them. And some software is not very well written or it's very complicated. For example, at the moment we have pledge support through 1zip, MAT, 1cached, Chromium, and some others. There were some efforts, for example, to add support for pledge to UNRAR, but there's a current case that doesn't work at the moment with a particular format, and the main reason is it doesn't be committed that reading the code, there's a current case with this particular format that should add a different capability, but we haven't figured out at the moment how to create this file to test, because it's an old version, a multi-volume version with a backup set. It's a complicated file. To develop pledge, we have tried a different way to catch the problem. That is, try to style the code. This could be easier or not, depends on the software and how well it's written and commented. Figure out all systems and call the program needs. Then add a promise in the code that only those operations are really needed. This you have to study also where to put this system call. Normally, you read the configuration file, then you open the sockets if they're needed, and then you would say from this part of the code downwards, you didn't need to open other sockets, for example, because you have just opened in the bottom of in the top half of the program. So you have to use, for example, FD passing to pass information from sockets to the program. Then I use tracing or GDB if something goes wrong, and loop, and go study the program and so on until you finish. The program is annotated with the pledge call. The kernel enforces annotations and kills the programs with an untrackable signifiers if one of these promises has not been respected. And there's no way to disable pledge. If a program has pledge support, you cannot disable in the kernel in any way pledge support. This is the main project. It's very easy. You have to define which promises you passes and which paths you want to apply. For path, at the moment it has been disabled support to check path because there are performance issues caused with a lot of path. On every call, the kernel will have to, if those paths were allowed, so there were some performance issues. We have to restart a better way to use this. The first promise, the minimal one, is blank. And if you pass a blank string to pledge, the only system call allowed is exit. So you cannot do anything. Then, step over, we have stdio. You can do malloc, you can do input-output. For example, cat is a program that works with SDA, only SDA your promise. Then you have access to read path, write path, create path, or access in TFP files. You have a feature to explicitly changes the file descriptor, so using chmod and similar codes. You have Unix and init. Yeah, there are two promises that can, all those promises can be combined, and you have those promises to open sockets in Unix sockets or init sockets. There's no difference, and we think there shouldn't be between init or init socket. There are a different one with DNS requests. Routine operations, sending file descriptor via some message to split in different processes the software and corresponding received message. Get PV to access password and group file access used by LS and France. IO controller is this has been split in several. Because with basic IO control, you have a very small subset of the IO control that are permitted. Then there are TTY to operate with TXX and France to the TTY operations. There are approach in which you can fork and kill processes, but you cannot execute a different program because there's exec to make the exec call. When you fork, the new process you fork is not pledged. So you can differentiate the program by forking more processes and then pledging the single process in different ways. Because one processor is, for example, accepting connections, and another one is reading files or writing stuff. You have set time. This is used mainly by NTPD to adjust the time. And the last one is BF. At the moment, we have all the promises. We think maybe we can add someone because the threaded programs needed some system call for threading operations, and we think we could maybe in the future add a different set. There's logging. On other OpenBSD version, there was a simple dmessage log on screen and on messages with a system call that fits. At the moment, we switched. We defined as pledge support as major, so we removed the message support and added only lastcom. So if you enable accounting, you have the pledge, the program that has been killed by pledge, reporting in the lastcom in the accounting file, and the daily script will mail you if there's something wrong during the day. There's a patch floating around to do syslog support, so the kernel itself will connect to syslog and write an entry in the syslog file. But at the moment, it's only patch floating. With accounting enabled, you can see all the program running, and then we have a load that is P, so it's being killed by pledge. And the corresponding report file is just an email which will say that this program has been killed by pledge this day. Then you have to investigate why. And so, very simple, stupid program that try to pledge only SDAO, and we have at the moment we have support for whitelist path, so we pass null in the pattern. He tried to printf and it will succeed. Then he tried to open a file and it will be killed. This is more or less a similar thing for Perl. We have at the moment support for many other languages, like at least there's a Perl, there's Node, and I think Python as well. In base we have the package manager, which is pledged, is written in Perl and is pledged, and adding support to the various software has been easier in base than in port. The main reason is that there are a lot of simple programs like Words, for example, which in only 2 lines you can add support for pledge, and oh, fine, thank you. And There are some that are more complex. With pledge, you can only restrict the promises. So you can have pledge studio or path GUI, and then you can have a subsequent call to pledge that restricts only to SDIO, for example, but you cannot add in another promise. So if another promise is needed later in the code, you have to rearrange the code to be able to fix this. Quite all daemons in base are privilege separated, so it's very easy to add the pledge calls in a single processes in a single files. Imports, a lot of processes, a lot of software is not privilege separated, so it's a bit more complex. Like this. This is memcached, and the main problem here is after studying the code is that, for example, you can use a Unix socket to connect to memcache, so you have to enable if it's defined settings.socket path. You have to use the Unix promise. If you're using a socket, you have to define init, but you won't define Unix because you cannot have a memcache. You cannot listen in the same process in memcache both on a Unix socket and on init socket. And if you're using a PD file, that's not by default in our port system, but it can be used. You have to also write this PD file, so you have to also add the correct cpath to create the PD file, and so on. And there are some of them that are more complex to catch all the possibilities of this code. Some of the patches has been committed upstream. At the moment, this one is not committed yet because another guy wrote a similar patch for seccomp for Linux, and it has a different implementation, and we have to rearrange the patch because we changed the in memcache. There's a method to drop privilege, because it's in Dart2.3 the support for I don't remember how it's called, because it's the same thing for Solaris, and so you have to use the same methods to add like support, seccomp support, and all those support all things. Okay. If something goes wrong, the kernel kills the file and creates core dump. If you try to use getrace, you have all the code that has been done, and it's clear that you try to open and you should need an read path promise, but it's operation not permitted. And then the problem is scale with imports. More or less the same with GDB, where you can see which line code is trying to open something that shouldn't do. So the future of pledge could be, we think that could be fixing the whitelist stuff, so to be able to open only some files in some folders, or only TMP files in varTMP or other TMP stuff. Probably adding syslog supports to be able to write in syslog files the not per meter operations, the way that you do not need to enable accounting, that in some server could be a problem to add all those informations. The other stuff is mostly related to ports, which is trying to add support to some interesting software that could be fine to add support for pledge, or postfix could be one, because it's privilege separated. It couldn't be so impossible to add support. Nginx or Apache could be worse. MySQL could be impossible, I think, because it's threaded, so it's more complicated. Then another thing we could do is adding pledge to some other operating system. It won't be that complicated to add support for Linux using syslog as base. So adding, for example, an additional layer to syslog, the way that if you do pledge stdio under the hood, the kernel which will write the BPF rule for syslog and terminates the program, or adding support for our BSD operating system that could have a kernel infrastructure that's similar to the OpenBSD one. Yeah.
So you mentioned that Chromium has been pledged.
Yeah.
What was the complication with Firefox, or has that been pledged now as well?
Chromium is privilege separated. Firefox is not.
And so the Chromium code base is also kind of a monster code base.
Yeah.
How difficult was it to actually pledge that code base?
It wasn't that difficult, because the Robert knows very well the Chromium code, because he's maintaining from the beginning. So for him, it was not. The problem is that the maintainers knows quite well the code of the software they maintain, but there are some software that have not an official maintainer, or the official maintainer is a bit slacking, so it has a few times.
So, of all the software that's been pledged so far, what's been the most difficult?
At the moment, I think there will be some stuff with math, because with math you can do to use I think makeup file. You can also add exec other stuff. For example, you have to add support for forking open GPGs to sign and so on. So it was a bit complicated, only to try to understand if it was better to add promises to all the stuff that Mac could do, or to disable some features to relate to things. And same has been done with links. And with links, we have disabled some stuff because otherwise you have to add everything, and so it has no sense.
And through the process of pledging all this stuff, was there any big surprises that was completely undiscovered until?
Some surprises is that some software were easier than we had thought. For example, BGPD was far easier than we thought in the beginning to apply support.
But anything that was kind of doing strange things that wouldn't be noticed normally?
Not too much.
Okay.
Yep.
You mentioned adding pledge to third-party software in general and the difficulties you had with upstreams.
Yeah.
Have you had any upstreams that were saying, "Oh, this is a great idea," or were they all like, "Oh, we don't want your OpenBSD nonsense"?
It's more. It's an interesting idea. I'll do it later.
I see. But if you give them the code, I mean, if you give them the patch, they just have to find.
Yeah, but it's in some cases it's more. I will have to add a lot of if-that code in my code, and it becomes a little strange. For example, Memcache was easier because it has a drop privilege function.
Yeah.
That it has if that Solaris includes this file, if that OpenBSD includes this file, and so on. So it was far easier to consider it for upstream inclusion. Some other you have to add if that code all around, and it's a bit difficult because well, nobody likes if that. Only OpenSSL. Yeah.
Is there any way to query what promises are existing at the moment?
No.
Except by doing strings on it.
Grab.
Yeah.
Grab the code.
Well, that assumes you've got the source code.
Yeah. Grab the source code. It's the only way.
You can run strings on it.
Yeah, people could put strings that look like promises in anyway. So there's no opportunity to do binary packages with this kind of thing in your port system.
We have patches.
Yeah, but how would I trust them that you've got the right promises in there?
Hmm?
How would I trust that you have the right promises in there?
I think the idea is that if you could invoke pledge and then exec something, allowing one exec to say get there, then you would encapsulate something else that hadn't been previously rejected by transferring the pledge to the thing that you invoke, something like that.
Okay.
And another way to, instead of using strings and so on, is that I don't know about BSDs, but Linux, you could make the pledge information available through /proc, so that you could then go and look at it. I think there is a proc on BSD now, isn't there? So you could store stashing the pledge information there to allow people to inspect colleges of the running processes.
But is the list of promises sensitive in a way? I mean, is it for an attacker it would be useful to know, right? If you're breaking.
I would assume that an attacker would know that anyway, because it's really restricting what the application will be able to do. I think there have been suggestions of doing more elaborate things where you have a path expression, a regular expression, some sort of expression saying this application will do the following things in the following order. It reads and writes, but sequence of reads and writes, but it will then do two reads, which might be wrong.
Yeah.
When you've had this switched on, have you noticed any, has it detected any actual attacks, or is it a bit too young for it to be able to do that? Sorry, for it to be a bit exposed enough to be able to be attacked?
For example, there was an attack to Memcached that was a remote execution and a DOS, and we only added the DOS and not remote execution, because you can kill with crafted packet. We cannot execute anything because pledge is killing the process, but you can kill the process.
Well, it's you limit the damage that it can do. So
Yeah.
Obviously, if it involves destroying something and restarting it, then you get kind of denial. So it's a bit hard to see how you could eliminate that possibility entirely, I think, because you can't make it go back and do the right thing. You can only detect the errors.
Does it always create a core file as well?
Yeah.
It gets a SIG
It's default in not only for pledge codes, but for every bug that crashes the system.
Well, yeah, I mean, you set
So
all
you have
limits to
always,
0 and
you
stop
have
the
always
program.
core files, and
Yeah, I'm just not sure I want core dumps for every file across the system. So, clever.
but could be a benefit or not.
Oh, yeah. Yeah, just
There's a SS control to be able to create the core files of the privileged separated daemons in a single directory in var crash something. So you have all the core files like that for further analysis, but you do not have them all across the file system. But if you crash ls for something, you have to core file in the current directory.
the standard I/O promise covers open, close, read, write.
Oh,
Well, you talked about the standard I/O
Team,
promise, yeah, and it covers standard I/O. Does it cover the system calls, open, close, read, write, mmap?
yeah. It's malloc, mmap, and read write.
Okay.
Thank you.